This is your homework day 2 of Unit 5, Lesson 1. This is problem number 28. It's very similar to question number 22. We're asked to solve each of the quadratic expressions by algebraic reasoning. So we're going to solve this one all by doing the algebra for the problems. So this is going to do 28. A is x squared plus 7 equals 23. So to solve this, we're going to solve for x squared. So the first thing I want to do is subtract the 7 from both sides. So I have x squared equals 23 minus 7. That would be 16. All right, so I have x squared equals 16. To solve this, I need to take the root of both sides. I get out that x equals 4 or negative 4. Now the reason I have negative 4 here too is that negative 4 squared equals the same that 4 squared does, equals 16. So I need both solutions. So I'm going to write there, you need both. Okay, that solves part A. Let's try part B. 3x squared minus 12 equals 135. I'll begin by adding 12, doing the opposite as a subtraction there. Add 12 to this side of the equal sign as well. I'm left with 3x squared on this side equals, I have a 7 there, and 3 plus 1 is 4. I get 147. I'm then going to divide by 3. Now, I haven't used my calculator yet, and I could jump to it at this point in time, but it's not a terrible time to remember how to long divide. Now, the reason I say that is in our next unit, we're going to need long division, maybe to help us do some factoring, and also to do some rational function graphing. So it's not a terrible time to do that. So what I'm going to do is take the 147, I'm going to divide by 3. Now, I got to remember that 3 can go into 14 4 times. 3 times 4 is 12. Right, I subtract the 4 minus the 2 here, and I get 2. Bring down the 7. 3 will fit into 27 9 times. So this now yields x squared equals 49. At this point in time, I'm going to square root both sides of the equation to get out that x is equal to, I'm going to put it a different way. I could put 7 or negative 7. I'm going to write it as plus or minus 7. That's the same as writing out x equals 7 or negative 7. Kind of a neat shortcut. Part C of 28 reads x squared plus 9 equals 0. I would begin by subtracting 9. Subtracting 9, I get x squared equals a negative 9. I'm going to square root both sides, and then something strange happens. I can't square root a negative number. There's not two numbers that multiply together to be a negative 9. The negative symbol is one of those times where you have to multiply an odd number of negatives to stay negative. And square roots imply you need an even number of things to multiply together. So this isn't going to work. So what I'm going to write is does not exist. If you were to try to take square root of negative 9 on a calculator, it would say non-real answer. We're going to explore what happens to this. We're going to define this later. But we're going to call this the square root of negative 9 is the same as square root of 9i, where I is an imaginary number, or it would be also equal to 3i. But it would be equal to plus or minus 3i. But at this point in time, I like the does not exist non-real answer first. Okay, let's go to D. I now have x plus 3 squared equals 19. I'm going to solve for x, so I want to undo the square first this time. So I'm going to square root 19. Now 19 is a prime number, so I know that 19 cannot be written nicely. Square root of 19 cannot be written as a nice integer. So if I want to, I can get a decimal approximation for this. So I probably will at this point in time. So I'm using my calculator. The square root's above the square button. I'm going to do the fast calculations. Okay, so I'm going to do the square root of 19. That gives me 4.35. It looks like a 9. So I'm going to write that out as x plus 3 equals 4.35. We'll go 89 since it's there. Then we'll subtract 3 from both sides. Answer minus 3. This is going to yield that x is equivalent to 1.3589. And that's my solution. Now, that's one solution, but I've got to be careful. This square root of 19 could have been negative as well. So I also should write x plus 3 is equal to a negative square root of 19, like so. Negative's not inside, it's outside. Well, if that was the case, if I do that, negative square root of 19, this is now going to be a negative 4.3589. And then I would subtract 3 like so. I would get that x is equal to a negative 7.3589. So those are my two solutions. Yep, there are two. Each of the quadratics have up to 2. All right, that ends question number 28.